The year is 2040. I'm hounding a prediction market to guess whether Sydney Sweeney will like the next TikTok she's live streaming. Everyone's on the edge of their seats. Will she like the TikTok or not? Large financial institutions are bidding on which next TikTok to show her, and that is a closed box system, except for insider traders who know we are serving the new Labubu Matcha TikTok. Most importantly, the streets have crumbled and everyone lives in a cardboard box. However, through new government social programs, everybody has been given an iPhone 20 and access to USB-C charging. The EU has decimated its population through regulation and being lame. What is there left to do but bet on celebrities' TikTok viewing habits? The entire system has been created to compress human behavior and modify it as efficiently as possible and financialize human behavior. What the hell was that? Where did that come from? All right, let's get started. All right. Wait, what the hell is going on? All right. Okay. So, all right. So should I go through the supplementary? I think. All right. Let me quickly go through the supplementary material. I feel like his supplementary material is so like um The kinetic enolate. Wait, no, the thermodynamic enolate is this. Hydrolysis of iminium. What happens here? What happens here too? Well, these are hard. So let's just say we have a ketone, and we have like a NHR. Okay, and then we're in base. I don't know what that base is at all, but I'm just gonna say we have base. So base. We get our enolate. No, wait. We're in acid. We have to be in hydrolysis is acid catalyzed. I don't know how to do it in base. No, we want acid. A ketone and acid. And so then NHR2 come in here. Okay, so I got the iminium. But then the thing about the iminium is that we do this. And we form the oh no, so this is more like a tautomerization, right? So the iminium to enamine transition is really not arrow pushing, but it's solvent mediated PT. So here we have our enamine. But now we're in heat. Why are we not getting the thermodynamic product? The thermodynamic product would definitely be there. To me, it seems like the alkene should be on the other side because we have heat, and so Okay, wait, let me understand. To me, what this is saying, and I don't know what C7H7SO3 is, um, but it seems to me that we are going to first protonate the carbonyl, and then we are going to do a substitution where we end up with an iminium ion. The iminium ion will tautomerize into an enamine, and the enamine um, has the alkene, and the alkene should be thermodynamic because of the presence of heat. This is definitely not the thermodynamic product. Okay, well, let's just say that we have. And we're reacting it with. Bro, what the hell happens here? So it's clearly setting us up for some sort of nucleophilic acyl substitution, and I'm refusing to look at whatever that is. But does it just do this? This seems wrong, but maybe it is literally this. This seems so wrong. Like what? So this is clearly that. Oh, there's also one extra carbon. Oh wait, no, I got it. Dude, I feel like I'm not. He didn't talk enough in the slides about thermo versus kinetic. And this I don't even begin to understand. I get that we have that. I mean, that must be what happens. Is that okay? Wait, I gotta get Stork down. Stork is crazy. So the I hate how bad and low quality these images are. Like, why is he doing this to us? All right, I think it's time to grind problems. This is what I think is the right thing to do. All right, I'm gonna attempt this, but keeping in mind that there's a pretty high probability that I totally give up on this. try to do this. Let's see if this is good. All right, so this is pretty easy, I think. So okay, let's do this. All right, let's do this. Oh, I thought I changed it. All right, so now we have the resonance forms of this molecule, but that's not even that important. So we have this. And we treated it with we're going to do an SN2 substitution reaction on an alkyl halide that's primary. So everything sort of checks out there. So then this is going to go to but there's another step here, which is okay. So wait, let me just do this. But this is equal to well, first let's do this. How do I do this? Oh, it doesn't. Okay, that's okay. What? But here we can do this. This is what I want to do. I don't even know why I'm spending so much time on this because I know the decarboxylation reaction. It's like, boom, boom. Actually, it has to be the pi. It can't be the lone. Is that the answer? Oh, wait, I just forgot this. Okay, that is the answer. Okay, next problem. Okay, so this is bromine gas. So wait, the first step I want to do is draw this. So wait, hold on. Let me. Pretty sure it's got to be this. This is just tautomerization. Acid catalyzed enol tautomerization. So we have we have the enol, and what happens now? Now this happens. Which I think is weird that halogens can do this kind of thing, but whatever. I think that's it. That is indeed the answer. Oh, wait. Okay. Next problem. I'm gonna start spamming these like really fast. So, so we're just gonna put the minus here, and then we're gonna have Are we given heat? Yeah, we are given heat. Okay. Is that it? I think that's it. Yeah, baby. Oh, fuck. I gotta keep my eye on this. I'll keep it zoomed out. Wow, the sunset is beautiful right now. Beautiful. All right, that was 3, 4. I'm just gonna spam these, man. I'm doing every one of these damn boys. All right. Okay. How am I gonna draw this? I think it should be probably like this. I think that's it. I think it's just showing kind of a synthesis strat that look, if we have access to this really acidic proton, we can do an SN2 on it and install, some sort of alkyl group onto it. But I think that that's it. Like, I don't see anything else that could happen. Yep. They actually drew it like uh, the answer key draws it like this. Like that. But it's the same. All right, easy enough. But this one I'm a little worried about. Not gonna lie. Because, all right, so it's warm. 25C is considered warm. Definitely in the more thermodynamic range. And we're adding the base to the ketone. So that means, basically catalytic base amount, maybe. It's more like you have a bunch of ketone and you add the base. Yeah, I mean, it's definitely kind of like this is more like a thermo thing. All right, so I always draw the analyte resonance forms. Because then I can do this. Oh, you know what? You know what? Here's what I missed. Okay, step 1, label all so we have this hydrogen and we have this hydrogen. The thing is, thermo favors the more substituted enol. So that's why we chose the one we did. If it was kinetic, this is the kinetic, we would get this enolate. Wait, do we? I don't even think we have a what? What the hell is that? And that would give us psi for cyclohexane. All right, so this is the answer, but we didn't add this yet. Yep, that's right. That's very right. Okay, we just did E. Now we're on F. I. Okay. So, all right, so this is kinetic. So the first thing we're going to do is we're going to draw it. 2, 4, 6. 4 methyl. Ketone there. Okay, now we have an alpha protons here. We also have an alpha protons here. So what's going to happen is this enolate is going to form. So and we can add our alkyl halide, which is it's like that. Oh my god, what am I doing, dude? That was insane. That was so bad. Here's what happens. If it was a Grignard reagent, it would be now we're going to add 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. Yep. These are getting real easy, boy. These are getting real easy. Okay, so the thing to note here is that there's no. I'll draw it. So there's no proton there. So we have to take this one. And what was the alkyl halide? It was 1, 2, 3, 4. 1, 2, 3, 4. Okay, I think it's that. So it's still not secondary. Probably a little bit less yield, but like it's still a primary alkyl halide. This carbon is this carbon. This carbon is this carbon. Am I right? Yes, I am. Okay, I think this one's a trick question that'll probably stump me. Oh, I actually remember the trick. Okay. This one's weird. All right, so the hint they give you is that they give you double base. Give me that extra base. All right, so your eye is drawn to these protons. But look, we also have these protons and these protons. Now, in a sense, these ones are degenerate on the ends. But what's the first thing that's going to happen? You put this stuff together, and this is going to happen, right? This is the first thing that happens. And because it's double stabilized, that's what's going on. Oh, I hate how I'm drawing these. You want sharp angles, you know? Okay, and then your mind says, you know what I want to have happen is... And I think probably that gets made... Oh, but you know what? It's one... So I think here's the other thing that happens though. And now the point is which charge is more stable? This is more stable. So because of the double resonance. So when we do 2, you know, I, this charge is going to come and hit that. And we're going to get. And then on workup, probably, you know, this minus comes here or something. But whatever. This is the product, and I'm positive that that's right. Which one is this? H? Yep. Okay, I'm gonna just start going through these and seeing which ones I can skip. Okay, so all right, we have a kinetic enolate that forms here. So this is a minus. This will go here. So this will just have a phenyl thing at the end. So let's look at I. Yeah. Okay. It's exactly as I predicted. Okay, J. All right, so first we're going to take off this proton. But then we also have alpha protons here, but there's no other alpha protons here. So, so we're going to take off both of these protons. And the thing is, this one is going to be less stabilized by resonance. So it's going to be the one that does the nucleophilic S2 attack. Okay, so I'm guessing that there's just going to be a methyl group right there on J. Ba-boom. Okay, now here we have a... is identical to B. So if this doesn't get brominated, I'm going to be so confused. Okay, that's exactly what happens. All right, here we have this no alpha protons here, terp butyl group, LDA THF, so super strong base. So we're pulling this off immediately. Because see here, this is a ketone, not a like a 1,3 diketone. So literally just a methyl group there. L, yeah, that one's easy. All right, M. All right, so here we have bromination. So what happens? This gets protonated, so this is a plus charge. But now the thing about this being a plus charge is you could think of like this being a carbocation a little bit. So what's going to happen is water is going to take this proton and form this alkene, and that is how we acid catalyzed form an enolate or an enol. So now we have an enol. So this is an OH. This is a single bond, and this is a double bond. And what happens is that then the charge character, the lone pair here of the OH, comes in here and pushes and hits this bromine. So bromine will end up right here. M. Now, if you had basic conditions, you could actually get away with, because the enolate, you can get a runaway thing where we could get 2 bromines there. But because they, yeah. Okay, here. Oh, we're allowed to skip this because we don't know anything about selenium. All right, so we got a basic little ketone here. Alpha protons or alpha hydrogens here and here. So this is going to just form a ring. You can see it so clearly. So this is a minus. SN2's to here. Should we do this one? This one seems fun. I'm down to do this one. Okay, so wait, I added an extra carbon. We're adding 1, 2, 3 carbon. 1, 2, 3. That's got to be it. Yep. Let's see. P. Oh, interesting. What does the base do? The base probably does an E2. Wait, oh no, you know what? Hold on, we gotta do this one. I know what's happening. He's trying to trick me. Yeah, he's trying to trick me, guys. So look, let's do this thing for real. So we have this thing, but then we also have this. So it's C O O at, yeah. Okay. So we have this. Because look, there's only 1 carbon here. So we have this, what is it called? Beta. Alright, I'll be back. I'm back, and I got a big bowl of peanut butter. Okay. All right, this one's easy. Is it a phenyl? No, it's a cyclohexyl. But then it's gonna do this thing too. So it's gonna be. Oh wait. Wait, but this is an OH. I think this might be it. Where's my answer key? P. Nice. 1, 2, 3, 4. Nice. All right, so now we're on the second set of problems. Okay. Thanks. So this gets a minus. Oh wait. I think I have to say whether it's yeah. Okay, so this is an Aldol reaction. Okay. I feel like Aldols are actually pretty hard for me, so I'm gonna practice. Okay. So all right, so this is gonna go like this and attack the. But oh yeah, and then this goes up here, and so we're gonna get and then here, this is an O minus, and this is a cyclohexyl group, and this hydrogen is still here. H. Okay, but what happens is, oh, we're gonna get a. This is interesting. So first off, the acid is going to hydrolyze both of the esters. So then we're going to get this. So HOOH, doom, doom. And this is going to be OH, and this is going to be, yeah, because, wait. No, yeah, that's right. Because it should look like this. But that's not what it looks like. So wait, hold on. This carbon is attached to 1, 2, 3. 1, 2, 3. Okay, never mind. We're good. So, but here's what happens though. This is the fun part. This is gonna be OH. This is carbonyl. This is OH. OH. Cyclohexyl. And it can multiple. It looks like multiple different decarboxylations could happen. Like, can we had have this though. So this is. But is it the same? It might be the same regardless of what happens. Okay, so in this case, this is gonna go like this. Which is equal to ket. So we're gonna have 1, 2, 3. This will be HO. So this carbon is this carbon. Let me go here. This is this carbon. Then we go here. This is this carbon. Sweet. Oh yeah, but see the thing is, look, we're in H3O. Wait, but to do the wait, hold on. We have to be careful because I think I did something wrong. Because before we do the acid workup step, we need to complete the aldol condensation, I think. Anyway, but let's try it again. All right. So we have okay, and we're doing the aldol. So we have, let's just say that it got this thing. But then this is what happens. We have this H here, and ETO minus comes in, pops that off, pops this off, pops this off. So then this is going to go to but the thing is, can we do this too? Fuck. Oh, wait. Because presumably we could take this proton too. So couldn't we? But anyways, I think that this is what happens because it's the most substitute. Actually, 1, 2, 3, 1, 2. Actually, I have no idea. I think it's the same. So then what about this? Can this form? Why am I so zoomed in? This is kind of a doozy of a problem. But it's definitely the case that you need to do the complete Aldol before the acid workup. I feel like that seems weird. Oh, and also, I feel like that's not right. What I would expect to really happen is probably this. So this gets cut off, and this becomes an alkene. So then we have. Oh, and this is probably OH actually, right? Yeah, it's a carboxylic acid. So what happens here is we have HO. Let me just draw the whole thing. Okay, so HO O O H. So we have HO OH alkene up. So this is alkene. Actually, this does not look right. Allene. There's no freaking way this is what happened. So but then it tautomerizes really quickly. Oh, but then it becomes conjugated. Yo, is this low key the this might be it. So that's kind of the two options that I'm seeing as possible. So what are we on? Are we on A? Oh, yes. Oh, but you know what? Oh, did I do the trans product? Yes. Okay, and I did say it's an Aldol. So see, that's the thing about these ones. These ones are pretty tricky, man. All right, but this is the answer. Yeah, because look, they're both. Yeah, I don't know. I feel like this probably could be made too. But this conjugated thing is more stable for sure. So it's like you just have to descend the tree and be like, all right. All right. ethyl propanoate and ethyl benzoate. Ethyl benzoate and ethyl propanoate. So we have two and but here's the key. No H. Okay. But here so first off, this is clearly a Claisen. Okay, wait. This is the part that really gets me. This carbon is this carbon. Okay, so we have this methyl down and up. I think that's it. I think that might be. Wait. Okay, I think that is the answer right here. Let's go. That's right. All right, problem C. All right, it's clearly a Michael. You can see an alpha beta unsaturated ketone. Wait, was it Claisen? It must have been Claisen. Yeah. All right, looky here. Okay. This is definitely the acidic, most acidic protons. Oh. Okay, so here. Okay, so we need to complete the. So I think that this is what happens. And we can assume that, but I need to check on that. So this is gonna end up like this. Then we hydrolyze this. Am I right? I actually don't even know. Nice. Okay, good. Why do I keep zooming in? Oh, this one reeks of Aldol. And then what is the conditions that make it proceed? I feel like it always proceeds for the most part. So then another base molecule comes here and kicks off hydroxide. So then our final aldol condensation will be this. Oh, but the thing is the E2, I forget. I think the E2 isn't that reversible, but the aldol addition is pretty reversible. They drew it really weird. But I think it's the same. The only thing I wonder is about the stereo cam. Because they probably drew it Z. It looks Z. No, it's probably E. I think it's right though. Here's how they drew it. I think it's the same. All right, so that's D. Okay. Shit, I actually have a lot left to do. I have a lot left to do. Okay. So why am I zoomed in? What is going on here? Why do I keep doing that? All right, so this goes like this, goes like this. That doesn't look right. Wait, because it's not. I think that's right. And this is a Claisen. It's a Claisen because it's I don't even know. Claisen is when like two esters attack each other. Yeah, I got it right. Mm, no, I have an extra carbon here. This is supposed to be like this. Yeah, it is. Okay, cool. That's it. That's good. Okay. At this point, it's becoming pretty automatic. So I'm wondering when I Chill the hell out. This is a Aldol. Let's just do this thing. My iPad thing sucks. Wait. 1, 2, 3, 4, 5. I don't know, something like this. Yeah, I mean, that looks right. Oh, actually, wait, let's start like this. This is how the answer key goes. So first, and that's it. Are there any surprises? I feel like there's got to be some more surprises. Oh yeah, and this was a hold on. Yeah, I'm gonna do every other one now. We're just gonna have to get lucky and whether or not they're good problems or not, because I can't really tell. All right, I mean, the thing about these that's kind of sucky is that it's like very obvious that decarboxylation happens just based on the reagents. But all right, let's. This is a Michael. Wait, hold on. This carbon bonds to this carbon. Something seems wrong here. But then this thing happens. The carbonyl reforms and this charge localizes here. But does that just take a proton? I would assume yes. No. But that's not all. So first we go to this, then we go to this. And this is no H. This is no H. And this happens. Then we go to my God. Because this forms and then this tautomerizes. Something like this. I honestly, and this is a what happened in this reaction? This is actually a Michael addition, yeah, Michael. And then a decarboxylation occurs. So this is H. Oh, nice, I got it. All right, good. All right, J. It's kind of more of the same. I'm gonna go to the next section here. I didn't see anything that looks like that insane here. All right, so we're gonna go to this. I don't know what's up with this one. This just looks like more Michaels. What the hell? It's like more of the same. All right, I'll do like 3 of these. I don't know. They're like the same though. I hate that whenever I put my palm down, it's like. Is it not something like this? I think this is right. Wait, wait. If we draw it like this, I think it's right. I think. Can I skip these problems? Like, what is new about these problems? They're all just Michael. This one's new. 11. What is this? This isn't an Aldol, but it's a Claisen. Oh, is this 6 is interesting. Is it? Oh yeah, okay. We have to do 6. Okay. Okay, wait. So 6. Okay, so 6, 7, 8. I'm just gonna go one by one because let me see how much of this thing is left. There's this page, then there's the enemies. Oh, and then there's kinetic versus thermal. Okay. Right, so there's not too much left of this. Maybe an hour of like good work left. All right. Problem 6. Because this is gonna be. Let's see. Is it it's ketones? I'm pretty sure this is going to be an intramolecular deals, not deals older. What the hell am I saying? Intramolecular aldol. Let's figure this out. So we get the question is so if we used thing to make this a minus, this like this, and then we made this the thing. I think that makes sense. It's gonna be like this, this. So really, if we were to redraw this, this O would be out here. And it would be a ketone. Wait, so this is the carbonyl. Wait, but this alkene has another thing like this. So then when we have a 6-member ring, so this is 6, 7. So this is 6 and this is 7. So this is 1, 2, 3, 4, 5, 6. 6 has a methyl on it. And this is, okay, wait, but 1 is directly connected to a phenyl, which doesn't make any sense. That's not right. Oh, but it's an intramolecular Diels Alder. So this thing goes up to here like this. So there's like a pH. That's kind of weird. But in any case, then I think this is the result. Actually, yeah, I think this might be the result. Please tell me I'm right. And I am. Good. Okay. That was a tricky one because, look, because you could take these protons down here. Why don't you take this from the alkene there? It's because you'd form a four-membered ring, which you obviously don't want to do. Or it's not, four-membered rings are not that good. So when you're doing intramolecular, all aldols, you want to be careful. All right, so, oh my god, this fucking iPad. Wait, this is wrong. No, it's not. But it's supposed to be like this. But why isn't it like that? 1, 2, 3. 1, 2, 3. Oh, it is. So confusing. So the base that takes it for real could just be ETO. Could just be this. But this isn't all, right? Because there's more stuff here, right? So there's actually an ethyl group here. I think this is the product. That's a nice looking product, man. I like that. Is that really what happens in 7? No, wait. Wait, hold the phone. I think it's just this. I think this methyl group is extra. If that methyl group is extra, then it'd be. What is here? This is a phenyl. Yeah. So we have O. Okay. All right. Okay, wait. 8 is freaky because. Wait, what just happened? Because I don't really get what's up with this. First, I don't really get what's up with this molecule. So this is clearly some sort of Michael thing. But it's a, oh, this looks like a stork enemy thing. I think this is stork enemy, which I really got to get locked down because that's probably the thing that I understand the least right now. So you have this like, I mean, is it literally just this? I don't even know if it's stork. I actually have no idea what's going on with this tertiary amine thing. Can you explain what's going on here? I see that it almost looks like some sort of Michael addition, but the weird part is that the only thing that seems nucleophilic attack enough to attack the Michael acceptor, which is the alpha beta unsaturated ketone, is the tertiary amine. The nitrogen. But the nitrogen is tertiary. So I don't know what this is. This is really weird. Because if it attacks, then it's quaternary and it has a formal positive charge. But what happens after that? Oh god, I'm so screwed for this midterm. Okay, I should have recognized N dimethyl. This is an enamine. That is the first step. Oh, wait. The enamine is like... Right. When you see an enemy, think, where is the mini mile? If you have an enemy and its residence form is the mini mile. Alright, I'm gonna go downstairs. I'm gonna end it now, I guess.